My name is Solomon Wete, and I'm doing this video for the assignment 1. I'm discussing the analysis of first fit and best fit memory allocation algorithms, the program that I've written. And then, so it's basically a way to test both the first fit and the best fit memory allocation strategies. So by running multiple allocation and the allocation cycles, you can observe memory fragmentation and performance differences. And then I also discuss the important and then the advantages and then the disadvantages of this algorithm, first fit and then best fit memory allocation algorithms. So I'll go to the code and then show you my code. So this is the code. This is the code for the program. So this is for the memory allocation simulation. This is the code for the memory allocation simulation. This is pretty much it. Everything is in the file. This is it. Yeah. This is for the memory allocation simulation. This is for the memory allocation simulation. The memory allocation simulation. This is for it. This is for the memory allocation simulation. This is the code for the memory allocation simulation. This is the code for it. And then also here is the code for the memory allocator. Here is the code for the memory allocator. This is the code for the memory allocator. This is the code for the memory allocator. It is the code for the memory allocator, and this is the code for the memory block. I'm going through it quick in order not to waste time, because the size of the file has to be very small. Sakai require us. This is the code for the memory block. This is the code for the memory block. Sakai require us to submit a minimal size of file on the platform. So I'll do this very quick in order for the size of the video not to be big. Something small that I can easily submit. So that is why I can't explain each of the code. So this is pretty much it. Right, I'll run it for you to see, and then we proceed. So it's running now. Okay. So to allocate first fit, we just have to enter the number 1 and then enter the size of the block you want to allocate. Let's say it's 8. Okay, and you press enter. So it has been allocated successfully. That is it here. So the size has been allocated. To allocate the best fit, you just have to enter 2 and then you allocate any size. Let me see 8. So okay. Yeah, so you see it has been allocated here successfully. Okay. And then to deallocate, if you enter 3, you can deallocate either best fit or first fit. Let me see the best fit. So the best fit, the figure, the block, the size we assigned to the block was 8. So let me just enter 8. And then it has been deallocated. The allocation field. Okay, so let me see. Let me do it again. Let me see. Okay, let me deallocate the first fit. The first fit is 88. Let me deallocate it. Yeah, okay. So the allocation is successful. I have just deallocated it. I can also deallocate the best fit now. And then I can show the memory too. So this is the size, the memory. This is probably the size, and then allocate it. Okay. So that is the code. This is what I've done so far. This is it for the code. Okay, I'll go to the disadvantages and then say the advantages of the program. So for first fit, some of the advantages are faster allocation time. So the allocation is stopped at the first available block, okay, making it more efficient in terms of execution time. So it has a faster allocation time. And then it also has a better performance in systems with frequent requests, because it quickly finds a block, and it deals for systems where memory requests are it's ideal for systems where memory requests are frequent and need quick response time. It's also simple to implement. So the logic in is just straightforward, requiring only a single pass through the memory list. So these are some of the advantages of first fit as a faster memory allocation time. It has a better performance in systems with frequent requests. It's also simple to implement. And some of the disadvantages are higher fragmentations. That is, it tends to leave small, unusable free memory blocks, leading to external fragmentations. And then wasted memory over time. Wasted memory over time. So that is, as more allocations and deallocations are occur, available memory becomes uh, 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 available memory becomes fragmented, making future allocations harder. So it has a wasted memory over time, and also less efficient for large allocations. I, in a first available block is too small. The search continues, making it inefficient in cases where large blocks are frequently requested. So it's best suited for systems like operating systems or like real-time systems. Example like operating systems and then embedded systems where allocation speed is more critical and more optimized. And it's also suited for general purpose computing where performance is preferred over optimal memory utilization. So that is for the first fit. It's best suited for real-time systems. And then for like example operating systems and embedded systems. Then also it's suited for if the general purpose computing where performance is preferred over optional memory utilizations. To go to the best fit, some of the advantages are it reduces fragmentations. It reduces fragmentation. That means it selects the smallest block that fits, leaving less wasted space. So it reduces fragmentations. It also maximizes memory utilizations. And it tends to leave fewer and smaller free memory gaps, making it suitable for environments with varying allocation sizes. So it maximizes memory allocations. And then also it's more efficient for large allocations because it optimally places processes. Large allocations can fit better without excessive fragmentation. So at the advantages, some of the advantages are it reduces fragmentations, it maximizes memory allocations, and as a more efficient, it's more efficient for large allocations. That is for the first fit. Some of the disadvantages of the best fit are it has a slow allocation time. It needs to scan the entire memory list to find the best fit, making it computationally more expensive. So it needs to scan the entire memory list to find the best fit. So it makes it more expensive. So it also has it may leave unusable small hooks. That is, if a block is split too finely, small remaining parts may become unusable over time. And then it also has a higher overhead. More processing is required for searching, making it inefficient in systems where speed is a priority. So that's some of the disadvantages for the best fit. And the best fit is most suited in memory constrained systems where reducing fragmentation is important. Example like the embedded systems with limited memory. And then also in database and cloud computing environments where memory efficiency outweighs allocation speeds, allocation speed. So and also in systems with predictable memory usage patterns where allocation requests are mostly similar in size. So, so it's best suited in memory constrained systems and then database and cloud computing environment where memory efficiency outweighs allocation speed. Systems with predictable memory usage patterns. So, to decide on which to use and then or which one to choose for a program, uh, I would suggest. I think for me, from my experience, if it will depend. It will depend because for me, I think that if you need speed and simplicity, uh, best fit will be the best. It will be the best option. If you really need to you want simplicity and speed, you have to use best fit. It's the better option. And then if you need to minimize fragmentation and optimize memory, best fit is the better option. So if you need speed and simplicity, first fit is the better option. And if you need the minimize fragmentation and optimize memory, best fit is the better option. So that is for me. That is for me. I think if, no, I think if you really need speed and simplicity, you should go for first fit. And if you need to minimize fragmentation and optimize memory, you should go for a the best fit is better. So that is how I went by the assignment. That is how I got it down. Okay, thank you.